Okay, so today we will start with equation of a line. In the last class, we have learned about finding gradient of a line. So let us start with this. So first we have to understand ki what does equation mean? Equation of a line. Uh, what does equation mean? So let us see. Like till now, we know any linear equation represent a line. What fact we know? Any linear equation represent a line. Okay, and then what is a linear equation? Represent a line. Then we have to understand what is linear equation. Linear mean any expression any expression where highest power of variable is one. What? Highest power of the variable is one is called linear equation. Okay, so have we understood first thing? The first and the note point is any linear equation will represent a line. And second thing, what is linear equation? What is linear equation? Any expression or any equation. Let me write since we are discussing about linear equation. So any equation, yes, any equation where highest power of the variable is 1. So this is first thing. Let us see some of the equations. So let us see when I write x plus y equals to 3. Is it a linear equation? Yes. What is the highest power of the variable? You can see what is the power of x? Nothing is here, so x is the power. What is the power of y? So nothing is, so we can clearly see the highest power of the variable in this equation is 1. Okay, so we are quite sure that x plus y equals to 3 will be a line. Agreed. Next, if I write this one, x equals to 3. Yes, this is also a linear equation. Why? Because highest power of the variable is x here, and the power of x is 1. So it is also a linear equation. This will represent a line. And similarly, if I write this, y equals to 2, it is also a line. If I write x equals to 0, this is also a line. Similarly, there are so many lines we have. Okay, how to represent this and how to draw this? X plus y equals to 3. What does it mean? So here we have to understand about equation. This is an equation. Any equation means what? What does it mean? Every equation is just a condition. What? Every equation is a condition. And what is a condition? See this line, which is line number 1 or equation number 1, line number 1. Equation number 1 is saying a condition that I want all those points. Line number one will collect all those points. All those points. It's a collection of basically it's a collection of all those points where x coordinate plus y coordinate equals how much? Equals 3. Okay, so when I write x plus y equals to 3, the line is x plus y equals to 3. It means we are looking for the collection of all those points where x plus y equals to 3. And if you ask me what is x plus y equals to 3, so it will go something like this. Please see this is what is the point of this one? This is 3 comma 0. If I add x plus y, x coordinate plus y coordinate, will I get 3? Yes. So this point is satisfying the condition. Similarly, this one, 0 comma 3. Yes. If you add x plus y, this is x coordinate, this is y coordinate. If you add, you are getting 3. Yes. So this is also satisfying this. Similarly, all next, let us say this one. This point is 2 comma 1. Suppose, is it satisfying? Yes. 2 comma 1. This is 1 comma 2. Yes, all these points are satisfying. So my line will be like this. And similarly, there are infinite points on this line. You can extend definitely line in this way also and this way also. Yes. So every equation is a condition. Okay, and line represent all those points who are satisfying that condition. Okay, here when I write x equals to 3, this one, when I write x equals to 3, What is it? I want all those points where x coordinate is 3. So this point is this point. I think x coordinate is 3. Similarly, this point is x coordinate 3. This point will have x coordinate 3. This point will have x coordinate 3. This point will have x coordinate 3. X coordinate equals to 3 means distance from y axis must be equals to 3. So yes, this time your line will be like this. Yeah. Similarly, we can get all the lines like y equals to 2 or x equals to 0 like this. Okay. Great. So I think we understood the meaning of equation. Equation is just a condition. Let us see different forms. This is important one where we will start with the first form. The first form. Let us write this as form 1. This is form 1. Form 1 is called gradient intercept form, and we will use this form to find the equation of line when we know the gradient and y-intercept of the line. Here intercept means y-intercept. What does intercept mean? Intercept always means y-intercept only. Y-intercept. And what does y-intercept mean? Y-intercept mean the point where you cut the line cuts the y-axis. The point where the line cuts the y-axis is called y-intercept. Let us take a situation like this. So this is the line. This is the line. Let us say, this is a point. Yes, this is a point where this is the line. I think y-intercept is this one. Let us call this point as C. This point as C. Mean ki the y-intercept is C mean this distance is C. This is origin and this is point A. Let us call this point A. So OA, the distance OA is how much? The distance OA is C basically. So do we have the coordinate of A basically? Yes, it will be 0 comma C. Yeah, true. And what we know the gradient of this line is, we know gradient equals to M. Yes, that's it. The gradient of this line is M, let us say. So to write the equation of any line, let us take any random point, any variable point. Let us say this is point P whose coordinate is x comma y. The point P whose coordinate is x comma y. Okay, P is any random point. You can take here, you can take here, you can take here, any random point. Okay. So now we will only try to understand any condition. We will try to find a condition. Since P is xy and A is 0c, so we have 2 points on the line. We have 2 points on the line. Definitely one point P in the terms of xy. And we know the gradient of this line is M. And I think the formula of gradient, we have this. Therefore, the gradient of line AP, let us call the gradient will be equals to what? Y2 minus y1 upon x2 minus x1, I think. Y2 minus y1 upon x2 minus x1. Here we need 2 points. Do we have 2 points? Yes, one point is A, one point is P. Let us say point P I am taking x2 y2 and point A I am taking first point as x1 y1. So let us substitute the values. This will be equals to how much? This will be M equals to y minus C, I think. Y minus C upon x minus 0. Yes, x minus 0. So if I do this way, then what I got? M equals to y minus C upon how much? X. Yeah. And if I do this, it is y minus C equals to mx. And then y equals to how much? Y equals to mx plus C. So this is the equation of the line. What equation we got? Equation of any curve or a line basically will involve variable x and variable y. Okay. So if you have a line whose gradient is M and one y-intercept is C, then the equation of the line will be, this is the equation of the line, will be y equals to mx plus C. Okay. If I show you an example, or let us take just the example. So this form is called gradient intercept form. Intercept form. We will use this when we have the gradient of the line and y-intercept of the line. Okay. So equation of the line, in that case, equation of the line will be y equals to mx plus c. Okay. Gradient intercept form. Let us take this question where I write down the in part A. Write down the gradient. Write down the gradient and y-intercept of the line. Okay, they have given you an equation. Y equals to minus 3x plus 2. Just now we saw this. This is in the form of y equals to mx plus c. Like this is exactly looking as y equals to mx plus c. So if I compare my line with the standard form y equals to mx plus c, that is gradient intercept form, we can clearly see that m will be minus 3 and c will be 2. It means here the gradient of the line, if I compare, if m equals to minus 3, you will get, and c will be equals to 2. Okay. And let us try to draw it also. Let us try to draw it. Okay. See, your C is 2. C means y coordinate. So the line is intersecting y axis at 2. Okay, so let us call this point as 2. Okay. And your gradient is minus 3. In the last class we learned for inclining line gradient is positive and for declining line gradient is negative. So here since my gradient is negative, therefore I am quite sure that the line is declining somewhere. Line is declining somewhere. Let us say the line is declining like this. This is approx. So we have approx idea of the line. Okay. What about part B here? What about part B? This is same as the equation is 4x minus 3y plus 5 equals to 0. So to find gradient and y-intercept, we will try to bring this equation into gradient intercept form. That is y equals to mx plus c. So y equals to mx plus c mean you have to make y as a subject. So let us shift 3y this side. So it will be 3y equals to 4x plus 5. And what about y? Y equals to 3 will go on division, so it will be 4 upon 3 x plus of 5 upon 3. And if you compare this with y equals to mx plus c form, we will get what? M equals to 4 by 3 and c equals to 5 by 3. Definitely again, this time also you can draw it. You can roughly draw it. C is 5 by 3. The value of 5 by 3 is how much? The value of 5 by 3 is 1.66. Yes. So this is 1.66 somewhere. Your y-intercept is 1.66, 5 by 3 or 5 by 3. Let me write this. And my gradient is 4 by 3. That is 1.33. Gradient is positive, so line is inclining line like this. Okay. We have drawn the exact idea. You can definitely we can extend it both the sides. Okay. So this is example 3. Let us take one more. Write down the equation. Okay. Here they want some specific form. In what form we are trying to get our equation? Ax plus by plus c equals to 0. It means all the terms to the left. In the right hand side, we just need 0. And second thing, first we will write x term, then y term, and then constant c. Okay. Y equals to, so let us see this way. Part A is y equals to 4x plus 3. We will shift everything to the right. It will be 0 equals to 4x minus y plus 3. That's it. And we can switch mean make right hand side to the left and left hand side to the right. So it will be 4x minus y plus 3 equals to 0. And now do we have ax plus by plus c equals to 0? Okay, let us do one more, because here they are demanding plus sign in between. Here they are demanding plus sign in between. So let's write this way: 4x plus of minus 1 times y and plus of 3. If I open the bracket, definitely I will get minus only. So now if I compare, yes, that now we have our equation in the form of ax plus by plus c equals to 0. And if we need the values of a, b, c, the coefficient, a is called the coefficient of x. A is the coefficient of x. So here a is 4, b is coefficient of y, that is minus 1, and c is 3. Yeah. Same way we can do this also. Y equals to how much? Y equals to minus 1 by 2x plus of 5. Yes. Okay, let us shift this way. So this will be 1 by 2x plus y minus 5 equals to 0. That's it. If I compare it, it is nothing but 1 by 2x plus of y and plus of minus 1 times minus 5. Let us write this one, plus of minus 5. Okay, equals to 0. And here ABC, we can get it. Okay, so this is example 4. Great. Let us take this example where the line this meets x-axis at point P. Okay, there is some line. There is some line, and line is y equals to 4x minus 8. And if I compare it with y equals to mx plus c, my gradient m is 4. And what about this? Yes. Uh, Work out the coordinate of p meets, I'm sorry, c is minus 8. Yeah, that's it. But here in the question, it cuts x-axis at point. Okay, let us draw the diagram. This one, y equals to mx plus c. It cuts y-axis at minus 8. Okay, y-intercept is minus 8. Anyway, that's, and gradient is positive, so that is why I have drawn like this. It cuts x-axis at some point p. Since p is a point on x-axis, therefore it will have y coordinate at 0. Let us take the coordinate of point p b. Let us take some x comma 0. Y coordinate will be 0. We know any point lying on the x-axis will have y coordinate as 0. Okay. So now we have to find this. Okay. Since p, the equation, what is the equation of this line? Y equals to 4x minus 8. And just now we saw equation is the condition to which all the points must satisfy. Therefore, since P is lying on this line, P is lying on this line. Therefore, P must satisfy this equation. It means we can substitute the coordinate of P in the equation. So, if I substitute x equals to 0 and x and 0, y equals to 0, so it will y equals 0 equals to 4x minus 8. 4x equals to 8, and x equals to 8 by 4, that is 2. Okay. Second, this is method 1. This is method 1 where what I said, since P is lying on the line, therefore you can substitute the coordinate of point P in the equation of the line. Method 2, shortcut. Okay, let us see the shortcut also. Shortcut says like this, for x-intercept, we put y equals to 0 in the equation of the line. We put y equals to 0. So I think, what is my equation? My equation of the line is this one, y equals to 4x minus 8. Let us put y equals to 0. So this will be 0 equals to 4x minus 8, and similarly x equals to 2 I get. What is the note point? Shortcut. Shortcut is for x intercept we put y equals to 0, and the other way, if you need to find y intercept, you put x equals to 0, the other way. So this was example 5. Till now we have understood just one form, that is gradient intercept form of a line. We will use this form to find the equation of the line when we have the gradient and intercept. Let us see the second form, or the other form. Okay. Yes. Form number 2 is all about gradient point form. We will use this form when we know the gradient and one point is known. Like, let us take this one. This is some line whose equation we need to find, and this is point A, whose point, let us say the coordinate b, the coordinate of b x1 comma y1. Okay, x1 comma y1 is the coordinate of point A, and we know gradient is what we know. Gradient is m. We have to find the equation of this line. Main key, find the condition. Equation is just a condition, so we have to find a condition that all points lying on this line must satisfy. For that, let us take a variable point p, and I am saying it, and the coordinate of b x comma y. Okay, the coordinate of point p x comma y. Again, I will use the same idea. Since I have these 2 points and I know the gradient is m, so gradient m is nothing but y2 minus y1. Same idea, I will y2 minus y1 upon x2 minus x1. So m is nothing but y2. Let us take p as second point and a as first point. So it will be y minus y1 upon x minus x1. Yes. And then what? If I do this way, yes. If I just shift x minus x1 to this side, I will get y minus y1. Okay. Let us shift this way. So m into x minus x1 equals to y minus y1. And let us just switch it. So I will get y minus y1 equals m into x minus x1. Correct. This is This form is called gradient point form. Gradient point form of a line. Okay, so if we have the coordinate of point be x1 y1 here, the node point x1 y1 is the coordinate of the point and m is the gradient of your line. So the equation of line will be y minus y1 equals m into x minus x1. Let us take questions now. So here we have a question. Find the equation of the line whose gradient is this and passes through this. Okay. So here this is point A whose coordinate is 3, 2. Let us, I have named it. And the gradient is how much? M equals to 5. Yeah. Yes. So we have the gradient and we have the point. Gradient, and so I will apply gradient point form. Gradient point form. What? Gradient point form we will apply. And as per gradient point form, what is the it is y minus y1 equals m into x minus x1, where x1 y1 is the coordinate of the point and m is the gradient of the line. Let us substitute it. Y minus y1, y1 will be 2, that is equals to m. M is 5 into x minus x1, x minus x1. X1 is 3, I guess. Let us all reduce it. So that is, this is y minus 2 equals 5x minus 5 3s are 15. Yes. And if I shift everything to this side, or let us take this way only, y equals to 5x and this is minus 15 and this is plus 2. This is minus 13. Yes, this is the equation of the line. And we have given, this time we have given equation of the line in y equals to mx plus c. That's it. So form 2 is gradient point form. If you know the gradient and point, then I will use this formula, y minus y1 equals m into x minus x1. Okay. Next and last form. See, one point. Without knowing these forms, also we can solve some way. But if we know the forms, the process becomes quite fast. Okay. By the way, learning formula of all the forms is not very much required. But if you just learn 3 different forms, it helps you a lot. It makes you quite fast, quite confident. Directly you jump on to the solution. 2-point form. Let us so this time we will have 2 points where this is point A, this is point B, where the coordinate of point AB, let us call it x1 y1, and the coordinate of point BB, let us call it x2 y2. Okay. Do we have the gradient of this line? Okay. Do we have the gradient of this line? Yes. I can get gradient somewhere, and yes, I have 1 point. Let us find gradient. And gradient is y2 minus y1 upon x2 minus x1. So gradient is y2 minus y1 upon x2 minus x1. Great, we have gradient and we have 1 point. Do we have gradient? Yes. Do we have 1 point? Yes. Let us apply gradient point form. Let us apply gradient point. And I'm taking point A as my point. Okay. That way, so gradient point form is, what is the gradient point form? Y minus y1 equals m into x minus x1. Yeah. So I can do it, y minus y1 equals m. In place of m, I will substitute this y2 minus y1 upon x2 minus x1 times x minus x1. Okay. Great. So what I am suggesting you to do for this one, this equation, can we write this way? This is y2 minus y1. This is in product here, y2 minus y1 into x minus x1. Can I shift this y2 minus y1 is in the division, because it is in product this side. If we shift, it will be in division. So the equation will be y minus y1 upon y2 minus y1 equals x minus x1 upon x2 minus x1. Yes, this form, yeah, I understand this is quite good formula to learn, but if you just say 1 or 2 times a bit fast, it will be learned. The form is y minus y1 upon y2 minus y1 equals to x minus x1 upon x2 minus x1. Because the form is quite same, so it is not very tough to remember. What is the name of this form? This form is 2-point form. And when we will apply this, we will apply this form when we have 2 points on the line. Yes, let us take questions based on this. Okay, so this is the question where yeah, Find the equation of line that is passing through this one. Okay, so there is a line. We have a line like this. This is point A and this is point B. The coordinate of point AB, the coordinate of point AB 5 comma 7, and the coordinate of point B is 3 comma minus 1. Okay, 3 comma minus 1. Yes. This is 5 comma minus 1. So since we have 2 point, we will use 2 point form as per 2 point form. 2 point form. And what is 2 point form? Uh, y minus y1 upon y2 minus y1 equals x minus x1 upon x2 minus x1. Here let us call b as x2 y2, and let us call this way. By the way, you can assume any one. This is my x2 and this is my y2, and the coordinate of point AB x1 y1 for sure. Let us substitute everything. So y minus y1 means 7 upon y2 minus y1. Y2 is minus 1, minus y1 is 7, I think. Yes, equals to x minus x1. X1 is 5 this time, upon x2 minus x1. X2 minus x1. X2 is 3 minus 5. Yes, we have to be careful while substituting the points. Okay, so we have it. So this will be equals to how much? Y minus 7 upon minus 1 minus 7 is minus 8 equals x minus 5 upon 3 minus 5 is minus 2. And now we can cross multiply. So this is equals to y minus 7 equals to minus 8 into x minus 5 upon minus 2. Minus minus cancel, and 2 4 ja you can cancel. So this is nothing but y minus 7 equals to 4x minus 20. And if I shift this way, so this is y equals to 4x minus 20 plus 7 is how much? Minus 13. So do we have the equation of the line? Yes, we have the equation of the line. Okay. By the way, this is a third form where y minus y1 upon y2 minus y1 equals to x minus x1 upon x2 minus x1. So this is about this is about three different forms of a straight line. That's it.